Two-way table, especially if you've worked with prepping for the SAT, you're probably experts at these because SAT loves two-way tables and loves having you read them. So, 3 different treatments that we have. We've got basically an herb, a prescription, and a placebo. Do we know what a placebo is? We'll talk more about it in chapter 4 when we talk about how we design studies and why we use placebos. But it's a sugar pill that doesn't do anything, but because people are getting a pill, it can still have a pretty powerful effect. And we'll talk more about that when we get there. But for now, those are the 3 different things that are going on. And here's our table. So, within this table, we can use what's called the marginal distributions, which are get this, the things in the margins. So if you look on the margins of the table, then you'll get the marginal distributions. That's why they're called that. And so if you're looking for the marginals, then it's basically giving the totals of each of the rows in each of the columns. And then the spaces in here, let me give some more space. So here's your grand total down here. These would be the marginals. And the stuff in here, a lot of times we call these the conditional parts of the table of the distribution. This is gonna start to tie in a lot when we start to talk about probability, and when we talk about conditional probabilities, we can get those tables. But for now, we just want to make sure that we can use these marginals and these totals to get some proportions and to make sure we can interpret the questions being asked. So, looking at this table, how many of the subjects had no response to the drug that they took? When you see the word of, that's a good indicator that we're talking about the denominator of whatever fraction we're going to write. So, of the subjects, well, that means we're out of everybody. Everybody is how many? 338. So, out of everybody, how many had no response? So we go back into our table. Look for no response. No response. How many of everybody had no response? Well, that's this right here, the 192. We're not interested in what they were prescribed. We're just interested in the response that they had. They had no response. 192 out of 338. And then if we wanted to, we could get a decimal out. But I'm just going to leave these as fractions. Well, unless it asks for percent, then I guess we'll put them. All right. What percent of all the subjects? So again, we're out of all the subjects, out of everybody. 338. How many took Zoloft? We're tracking all the ones that took Zoloft. 109. And again, these are marginal cells of the table. These are the marginal pieces of the table. The ones on the margins, it gives all the totals. So 109. Go for it.
I transferred from a school where they didn't do percents, and then they skipped percents when I came to Reagan because they skipped a year in between because my school wasn't as forward. I got the decimal.
Yep.
I understand that that's the decimal.
0.3225.
Okay.
Here's the idea.
Yes.
Because 0.3225 is out of 1. Remember, the decimals is everything adds up to 1. But human beings don't like decimals. I just want a number. A decimal is a number, but for some reason, people just want a number. And so instead of being out of 1, let's put it out of 100. And the way that we scale that is by multiplying everything by 100. Or the way that it's usually taught is move the decimal 2 places to the right, because that's what multiplying by 100 is going to do. So 0.3225, scale it up to be by 100, will turn into 32.25%. It's called percent because it's per 100.
Okay. Am I the only one who knows how to
Percent is per, because again, when you cover percentages, they make that connection between the word and what it's tied to. It's scaling it out of 100. Usually we're actually going to work in decimals, but sometimes we'll convert to percentages. If it asks for a proportion, then it just wants the decimal. Percent, scale it up to out of 100, which will move it 2 places to the right. Anything else before we go on? All right. Now, the cells are basically each spot in the table. So when I say a cell, that's what I'm talking about. Hopefully, if you've worked with Excel or the matrix function on your calculator, then you might be a little bit familiar with that. So how many took the placebo and had no response? We look in the table. We look for placebo. We look for no response. We look where they cross. It's at 66. It's also possible to use relative frequencies, but there are several ways this can be done. So this is where we're talking about all 3 of these are going to involve 66, but the rest of the answer is going to be different. Your answer should have 66 in it, but all 3 are going to be slightly different. I just want the fraction. So the people who took placebo and had no response, proportion of people who did this. So that means we're out of everybody. How much was that again? 338? Be looking back at the table as I do this because it's on a different slide for me. Proportion of placebo users that had no response. So we want to go 66 out of all the placebo users. How many placebo users were there? 116? Okay. And then proportion of people with no response who took the placebo. So out of all the people that had no response, how many was that? 192. 192? Okay. So those are going to be very different proportions or percentages when you work those out. So make sure you're paying close attention to which of those it's asking. Now there are 2 different ways you can do the conditional distribution. Is that we are interested in, it looks like what we're interested in here is we're fixing one of the variables. So let's start with the placebo over here. So the placebo. Out of everyone who took the placebo, and then we're going to figure out what are the percentages of people who had full response, partial response, or no response. So this is slightly different than just keeping count. It's turning that into percentages that you can get out. Placebo, we had out of how many total took the placebo? 66? No. All of the ones who took the placebo, it should be the number that's here. Okay, so all of these are going to be out of 116. Out of those 116, how many had full response? And the idea is when we do these three percentages, they should add up to 100. And we're using it, here's what we're using this for. We're using it to directly compare what proportion of the placebo users had each type of response. We're breaking it down just based on the placebo users. So give me some percentages here.
The first one is 30,
90. Okay. This should be smaller. 11.20 to 1. That's what we said.
90.
With a little bit of rounding error, if you add those three up, they should add to about 100%. So out of the ones that took the placebo, and we can just focus in on the placebo data, we can see that we have about 56%, 11%, 31%. Or, depending on what we're looking for, we could do this conditional the other way and just focus in on, out of all the ones that had no response, make that 100% and say how many of them came from the herb, how many came from the pill, how many came from the placebo. So those are you can do it the other way, and that just gives you a different comparison to make. Segment and bar chart. So we can use these conditional values. We want to turn this into a graph to be able to make a nice, clean comparison. And one way we can do this is by using a segment and bar chart. You can think of it as combining the idea of a pie chart where we combine the percentages together with a bar chart where we're comparing different bars on different sets on different categories. It's a way to turn a two-way table into a nice graph. So this is an idea. This is actually for it's probably as of like 3 or 4 years ago where our district was at. So you'll see that they took the conditional distribution for just the school and said what percent met or exceeded, what percent were approaching, what percent partially met, what percent did not meet. That's in comparison to the entire district, what percent exceeded, what percent. And so they got these for each of the rows and then segments out the bars for each of those different ones. Okay, so I want to go back. And first off, I want you to get the rest of these values. So for example, for Zoloft, what should all these be out of? 10 what? 109. And get those percentages, and then see if you can turn that into a segmented bar chart. But you should, we'll eventually start to talk about whether one of the variables has to do with the other, whether one of the variables depends on the other in some way. So in this case, we'd be looking for, is their level of response having an association with what prescription they got put on? That's what we might be hoping to measure, whether one of them happens to have an association with the other. Okay, but here's a more advanced idea of two-way tables. Well, you take a look at some of these percentages. So this is these are the players, and I want you to think about maybe you've got someone. Maybe you're going against a team that's going to have a starting pitcher that's a lefty, but their relief pitcher's a righty. So you might have to have them facing both. So based on these percentages, who would you want to start and why? You thinking about that? Question. And you should notice something going on. This is a paradox that's called Simpson's paradox that has to do with these proportions. So who has a better total batting average, A or B? I'm going to put green for winner. They're a winner. Overall, who has better batting average against right-handed pitchers? B. Who has a better batting average against left-handed pitchers? B. So they do better against righties and better against lefties, but they're a worse hitter.
But look at the numbers.
What's happening? What about the numbers?
Well,
So this is the idea behind the paradox is when you start to combine the proportions and say overall how are they doing, one seems to be doing better than the other. But then over here, if you break it down in pieces, then the other is better. So why is that happening? Overall, do they do better against righties or against lefties? Right. They do better against righties. So for batting averages to be high, then the player would have to go against right-handed pitchers a lot more. Who's doing that, A or B? A is going against righties more. They're having to go against lefties a lot less, which both of them are worse against. And by contrast, player B is going up against lefties, which they're finding it harder to hit against, a lot more. And so that's causing their overall batting average to go down and causing player A to have a much better batting average. And so the idea is when you're combining together your proportions, you need to be careful with it because you want to look at, especially if some of these high percentages are small, are out of a small amount of data, then it can make the data look a different way than it actually is when you break it down into pieces than when you combine them. That's the idea of the paradox. And we'll look at it when we come back on Monday, or Tuesday for you guys. When we come back on Tuesday, we'll look at another example for that so that you can get your mind wrapped around it again. Right? So tomorrow, make sure you tune in and follow along because we're going to be doing those. We're going to be starting the next set of notes.